Recklinck-Lehrs Airfield, northeast Germany. Hauptmann Friedrich Weber stands in a guarded hangar, staring at a device that 48 hours ago was inside an American bomber. The Boeing B-17 Flying Fortress had been shot down 2 days earlier during the catastrophic Schweinfurt-Regensburg raids, 60 bombers lost. The largest single-day loss for the Americans since they began operations from England. This bomber came down near the Dutch border. The bombardier hadn't destroyed it. Standard protocol required smashing the device with a service pistol, immolating it with thermite, or throwing it from the aircraft. But in the chaos of fighters tearing through the formation, hydraulic lines severed, 2 engines on fire, the crew had other priorities. They bailed out. The bomber flew into a field. And the Norden Bombsight, America's billion-dollar secret, sat intact in the wreckage. Weber is a 34-year-old optical engineer. Before the war, he worked at Carl Zeiss, designing precision instruments for surveying and artillery ranging. When the Luftwaffe expanded its technical branch in 1940, they recruited him, his specialty, bombsight evaluation and development. He's examined captured British bombsights, analysed reconnaissance photographs of Soviet equipment, studied intelligence reports on American technology, but this is different. This is the device that American propaganda has turned into legend. The bombsight that supposedly lets bombardiers drop bombs into pickle barrels from 20,000 feet. The weapon is so secret that armed guards escort it to and from aircraft. The instrument that every American bombardier swears a solemn oath to protect with his life. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Weber circles the device slowly, notebook in hand. The Norden consists of 2 primary components connected by the sighting prism. On the left, a gyroscopic stabilization platform, roughly 40 centimeters square, 15 centimeters tall, heavy. He estimates 20 kilograms. The platform sits on a mounting bracket designed to attach to the bomber's structure. 3 gyroscopes inside, spinning at high speed, maintaining a stable reference platform regardless of the aircraft's motion. On the right, the mechanical calculator and sighting head, another 15 kilograms of precision machinery, gears, cams, mechanical integrators. An analog computer solving differential equations in real time. Between them, the sighting eyepiece, a small telescope that the bombardier looks through, connected to both the stabilizer and the computer. The entire assembly, painted olive drab, shows excellent manufacturing quality, no rough edges, no visible shortcuts in construction. An Oberst from Luftwaffe intelligence stands nearby. Colonel Hans Meyer, Technical Intelligence Directorate. He's been at Recklinck since dawn, waiting for Weber's assessment. The Abwehr wants a full report by tomorrow morning. Reich Marshal Göring personally requested updates. Everyone wants to know. Is this the miracle device that explains American bombing accuracy? Weber knows something the Oberst doesn't. Something that makes this entire examination feel like theatre. He knows Norden's secrets aren't secret at all. November 1937. A drafting table at the Carl L. Norden Company, 80 Lafayette Street, Manhattan. Hermann Lang, 36 years old, German immigrant, naturalized American citizen, assembly inspector at Nordens factory, leans over technical drawings. The Norden Mark 15 bombsight, latest production model. Complete schematics, gyroscope assemblies, mechanical computer design, autopilot integration, optical system specifications. Lang has an excellent visual memory. He studies the drawings during his lunch break, during overtime, any moment he can access. The engineering department. He doesn't photograph them. Too risky. He memorizes them. Dimensions, tolerances, assembly sequences. Night after night, he goes home to his apartment in Queens, and reconstructs what he's seen. Hand-drawn schematics, technical notes, manufacturing specifications. By March 1938, he has a complete set of plans. The delivery method is almost comically simple. Ocean liner, first-class passenger, the drawings, rolled in a tube, labeled as commercial surveying equipment documentation. From New York to Hamburg. Customs officers don't look twice at technical documents. They're looking for weapons, contraband, and political materials, not engineering drawings. The tube arrived at Abwehr headquarters in Hamburg in April 1938. Oberst Nikolaus Ritter, Abwehr Luft, Signals Division, examines the contents. He immediately recognizes their value. Within a week, the plans are forwarded to Carl Zeiss in Jena, the company that manufactures Germany's most advanced optical instruments, the company that produces the Lotfernrohr bombsights for the Luftwaffe. Zeiss engineers spread the Norden plans across their tables. Dr. Heinrich Mu, chief optical designer, leads the evaluation. He brings 30 years of precision instrument experience. He's designed artillery rangefinders, periscopes for submarines, and astronomical telescopes. He examines the Norden design with professional interest. The gyroscope system is sophisticated, 3 gyros providing complete stabilization in all axes. The mechanical computer is clever, using gear trains and cam profiles to solve ballistic calculations continuously. The autopilot integration is the most innovative aspect. The bombsight doesn't just calculate when to drop bombs, it actually flies the aircraft during the final approach, making micro-corrections for wind, ensuring the bomber follows the exact trajectory required. Müller makes detailed notes, but his conclusion surprises Abwehr, intelligence, when he delivers it in June 1938. The Norden Bombsight represents excellent American engineering. However, it is not superior to German technology. The complexity is remarkable, but also a weakness. The system requires 2 separate units that must be precisely calibrated and maintained. The gyroscopes need lengthy spin-up time. The autopilot integration demands sophisticated electrical connections that are vulnerable to combat damage. Most critically, the entire system depends on the bombardier having sufficient time for setup and adjustment, at least 10 minutes of stable flight before reaching the target. In combat conditions, with fighters attacking and flak bursting around the aircraft, this represents a significant operational constraint. Müller recommends Germany continue developing the Lotfernrohr 7. The Lotfes 7 uses similar principles: gyroscopic stabilization, tachometric calculation of ground speed, automatic bomb release, but it's simpler. A. Single unit instead of 2 separate assemblies. Faster operation. More robust. Less vulnerable to combat damage. The Norden plans are filed away, useful for understanding American capabilities, but not worth copying. Germany has its own path. Back in the Rechlin hangar, August 1943, Weber knows all of this. He was at Zeiss when Müller evaluated the stolen plans. He participated in Lotte 7 development. He understands that the device in front of him contains no surprises, no secret technologies, no revolutionary innovations. But he still needs to examine it, not to learn its secrets, to confirm that American production bombsights match the 1938 drawings, to verify that 5 years of war haven't forced the Americans to make compromises in manufacturing. He begins the technical inspection. First, the stabilization platform. Weber carefully removes the access panels. The gyroscopes inside are mounted on a precisely machined frame. Each gyro is a self-contained unit. Electric motor, spinning rotor, gimbal mounts allowing free movement in all axes. The machining quality is excellent, bearing surfaces smooth. No visible manufacturing defects. The motors are small but powerful. Weber estimates they spin the gyros at 15 to 20,000 revolutions per minute. The gyroscopic rigidity provides the stable platform for all subsequent calculations. He examines the leveling mechanism, small spirit levels, visible through glass windows on the platform's face. Before each mission, the bombardier must manually adjust the platform until the bubble levels show it's perfectly horizontal. This process, Weber knows, takes 10 to 15 minutes. A skilled operator might manage 8 minutes in ideal conditions, but in a cold bomber at 25,000 feet, wearing heavy gloves, with an oxygen mask restricting movement, it takes longer. The mechanical computer is more complex. Weber removes the top cover, revealing an intricate arrangement of gears, cams, and linkages. The computer solves a continuous ballistic equation. Given inputs for altitude, airspeed, wind velocity, and bomb ballistics, it calculates the exact moment for release. But the elegance lies in how it obtains these inputs. Altitude comes from the aircraft's instruments, airspeed similarly. But wind velocity? That's the clever part. The bombardier sights on the target through the telescope. As the aircraft approaches, the apparent motion of the target reveals the ground speed. Compare ground speed to airspeed, and you can calculate wind effect. The computer does this mechanically. A motor drives a mirror in the telescope, rotating it to keep the target stationary in the sight. The rate of rotation directly corresponds to ground speed. Gears translate that rotation into wind calculations. Weber traces the gear train with his finger. Each gear is precisely cut, tolerances held to hundredths of a millimeter. The manufacturing sophistication suggests dedicated machine tools, skilled machinists, quality control processes that don't allow shortcuts. He thinks about German bombsight production. Zeiss manufactures perhaps 200 Lotte, 7 units per month. Maximum capacity. They're limited by the supply of high-grade optical glass, by the availability of precision machine tools, by the number of skilled craftsmen who can assemble complex instruments. How many Nordens are the Americans building? Intelligence estimates suggest 400 to 500 per month, from multiple factories. Victor Adding Machine Company in Chicago, Remington Rand, even the original Norden plant in New York. Mass production of precision instruments. It shouldn't be possible. Precision instruments require hand-fitting, individual adjustment, and skilled assembly. You can't just stamp them out like rifle parts. Yet apparently, the Americans can. Weber examines the autopilot connection. Heavy electrical cables run from the bomb site to the aircraft's autopilot system. During the bomb run, the bombardier engages a clutch. The bomb site takes control of the aircraft's flight surfaces. If wind pushes the bomber left, the bomb site commands the autopilot to correct right. If airspeed drops, it adjusts the throttles. The bomber becomes, essentially, a guided missile. The bombardier just watches through the sight. When the calculated release point arrives, the bombs drop automatically. No human reaction time, no error from manual release, pure mechanical precision. In theory. Weber knows the reality is different. He's read intelligence reports from Luftwaffe pilots. They describe formations of hundreds of B-17 seconds. The lead aircraft uses the Norden. The bombardier in that aircraft aims carefully, makes his calculations, and engages the autopilot. The other bombardiers in the formation watch. When they see the lead aircraft's bombs drop, they release theirs immediately. Pattern bombing, not precision bombing. Because precision, bombing doesn't work in combat conditions. The mathematics is simple. A bomb released from 25,000 feet falls for approximately 40 seconds. During that time, it travels forward with the bomber's speed, roughly 2.5 kilometers horizontal travel. The bomb sight must calculate the exact release point 2.5 kilometers before the target. Any error in altitude measurement, 100 feet, translates to 60 meters of missed distance. Any error in airspeed, 5 knots, another 40 meters. Wind estimation error, 3 knots crosswind, another 30 meters. Temperature variations affect bomb ballistics. Barometric pressure changes alter altitude readings. Small errors compound. Norden's theoretical accuracy, under perfect conditions, on a test range, with no combat stress, might achieve a circular error of 75 meters. In combat, with fighters attacking, flak bursting, the bomber taking evasive action, crews exhausted, equipment not perfectly maintained, 300 to 400 meters becomes typical. Weber makes careful notes. The Norden represents exactly what the stolen plans indicated: sophisticated mechanism, excellent manufacturing, impressive engineering, but not a miracle weapon. Just another bomb sight, more complex than Germany's, achieving similar results under combat conditions. He photographs every component, documents the serial numbers, records the manufacturing codes stamped on various parts. This information will help intelligence track American production facilities, understand their manufacturing processes. After 4 hours, Weber closes his notebook. The examination is complete. He has learned nothing that Germany didn't already know from the 1938 plans, but he has confirmed something important. American industrial capacity allows them to mass-produce precision instruments at a scale Germany cannot match. That evening, Weber wrote his report. Oberst Meyer reads it in silence. Toward the end, Weber includes a section that makes Meyer uncomfortable. The Norden Bombsight demonstrates American manufacturing sophistication that exceeds German capabilities. The device contains approximately 1,200 individual parts. Each part is precisely manufactured to tight tolerances. The gyroscopes alone require bearing surfaces ground to optical flatness. The gears must be cut with precision that allows no backlash. Yet the Americans are producing these devices at a rate of 500 per month. This suggests several concerning conclusions. First, American machine tool technology allows precision manufacturing at production scale. Second, their quality control processes maintain tolerances across large production runs. Third, they have sufficient numbers of skilled technicians to assemble complex instruments rapidly. Fourth, they possess adequate supplies of strategic materials, particularly high-grade steel, aluminum alloys, optical glass, and precision bearings. Germany cannot match any of these capabilities. Our precision instrument production is limited by machine tool availability, skilled labor shortages, and strategic material constraints. Zeiss manufactures approximately 200 Lotte 7 bomb sights monthly. Increasing production would require diverting resources from other optical instruments, gun sights, rangefinders, and periscopes. The Americans face no such constraints. They can produce bomb sights, gun sights, and all other precision instruments simultaneously, in quantities that suggest effectively unlimited industrial capacity. Meyer puts down the report. Look at Weber. Your technical assessment is clear. But this conclusion, about industrial capacity, goes beyond your assignment. Weber meets his gaze. Herr Oberst, you asked for a complete analysis. I cannot evaluate the bomb sight without considering what its production rate reveals about American industry. And what does it reveal? That we are in a production war we cannot win. We can build better aircraft, better tanks, better optical instruments. Our engineers are skilled, our designs are sophisticated, but the Americans can build adequate equipment in quantities that overwhelm quality. One German tank may be worth 3 American tanks, but if the Americans can build 5 tanks for every one of ours, we lose. Silence. Then Meyer speaks quietly. Your report will go to Luftwaffe Command. I will include your technical findings. The section about industrial capacity I will mark as speculative analysis. Outside the primary scope, Weber understands. Truth is dangerous when it contradicts official optimism. You can include it or exclude it, Herr Oberst. The facts remain the same. The Norden Bombsight is not a superweapon, but the industrial system that produces 500 per month is. Weber leaves Rechlin the next morning. Return to Zeiss. Back to work on Lotte, 7 improvements. The captured Norden sits in the hangar for another week, then is shipped to Berlin, displayed to Luftwaffe officers, used for training intelligence analysts, eventually ends up in storage. One captured device among dozens collected throughout the war. The examination changes nothing. The war continues. American bombers keep coming, more and more of them, each carrying a Norden bombsight, not because the Norden is miraculous, because American industry can produce them faster than Germany can shoot down the bombers carrying them. January 1941. Carl Zeiss, Factory, Jena, Germany. The Lotfernrohr 7C reaches production readiness. Dr. Heinrich Müller examines the first production unit with satisfaction. 3 years of development, incorporating lessons from the Norden plans, improving on German bombsight tradition. The Lotte 7C represents a different philosophy than the American approach. Where the Norden uses complexity to achieve precision, the Lotte 7C uses simplicity to achieve reliability. The device is compact, a single metal box, roughly 30 centimeters long, 20 centimeters wide, 15 centimeters tall, weight 8 kilograms, half the weight of the Norden stabilizer alone. Below the box, a tube extends downward, the rohr, they call it, mirror tube. It projects through the bomber's fuselage, ending in a small fairing under the aircraft with a flat optical window. Inside the tube, a mirror reflects the ground image upward into the telescope in the main box. The entire mechanism, gyroscopes, computer, optics, fits in that single housing. No separate stabilizer platform. No complex cable connections. Just one unit that mounts in the aircraft nose. Power connection, autopilot connection, done. Müller explains the design philosophy to visiting Luftwaffe officers. The American Norden requires the bombardier to locate a test target offset from the actual target. He must synchronize on this test target to calibrate the system. Then he must shift to the actual target for the bomb run. This takes time, requires perfect visibility. Our Lotfes 7 allows the bombardier to sight directly on the target from 90 degrees in front of the aircraft all the way to 40 degrees. He never needs to shift targets. He simply keeps the target centered in the crosshairs. The device calculates everything automatically. One officer asks about accuracy. Müller is honest. Under ideal conditions, the Lotfes 7 achieves circular error of approximately 80 meters from 8,000 meters altitude, similar to the Norden. Under combat conditions, both systems degrade to 200 to 300 meters. The limiting factor is not the bombsight. It's a combat environment, evasive maneuvers, flak bursts shaking the aircraft, fighters forcing the formation to break, temperature variations at altitude affecting bomb ballistics. No bombsight can compensate for these factors, but the Light 7 has advantages. Setup time is 3 minutes versus 10 minutes for the Norden. The aircraft takes damage. The Lot 7 is one self-contained unit. If it fails, replace it. The Norden requires both the stabilizer and the computer to function. If either fails, the entire system is useless. Our system is more robust, more suitable for combat operations. The Luftwaffe orders full production. By mid-1941, Lotfe 7C units begin reaching bomber squadrons. Heinkel He 111 bombers, Junkers due 88 seconds. The bombardiers receive training. Most prefer it to the older Lotfernrohr 3. Simpler operation, more reliable, better results. But by 1941, Germany's strategic bombing campaign was essentially over. The Battle of Britain failed. The Luftwaffe shifted to tactical support for ground forces. The push into Russia demands close air support, not high-altitude precision bombing. The Lotfes 7 becomes a solution without a mission. It equips bombers that increasingly operate at medium altitudes against tactical targets, where dive bombing or low-level attack proves more effective than level bombing from 8,000 meters. The sophisticated bombsight sits unused, while Stuka dive bombers and medium bombers at low altitude do the actual work. Weber knows this. Sitting at Zeiss in 1943, working on Lotfes 7D variants for jet bombers that may never see production, he understands the strategic irony. Germany developed an excellent bombsight. America developed a comparable bombsight. But America uses theirs. Thousands of bombers, hundreds of missions, day after day, while Germany's bombsight equips a shrinking bomber force conducting fewer and fewer strategic missions. August 1943. The same week, Weber examines the captured Norden, 8th Air Force Headquarters, High Wycombe, England. General Ira Eaker reviews casualty reports from the Schweinfurt-Regensburg raids. 60 B-17 seconds lost in one day. 600 men, some dead, some prisoners, some injured and interned in Switzerland. The replacement rate cannot keep pace. B-17 production is high. 500 per month and increasing. Finding crews is harder. Training a bomber crew takes months. Pilot training, 8 months. Bombardier training, 12 weeks. Navigator, gunnery, specialized positions. Each man requires extensive preparation. Lose 60 crews in one day, and you cannot replace them in a week. The bombing results are mixed. Regensburg, significant damage to Messerschmitt factories. Production disrupted for weeks. Schweinfurt, hits on ball-bearing plants but not enough to stop production. German industry proves resilient. They disperse factories, stockpile critical components, increase production elsewhere to compensate. The strategic bombing doctrine assumes precision attacks on vital targets will cripple German war production. The Norden Bombsight is central to this doctrine. With the Norden, bombardiers can supposedly hit specific factory buildings, specific railroad yards, specific power plants, precision bombing, not area bombing like the British. But the reality emerging from combat operations shows precision bombing is harder than predicted. Colonel Curtis LeMay, commander of the 4th Bombardment Wing, understands the problem. He's flown combat missions himself, watched the bombing patterns. The Norden works perfectly on training ranges in the United States. Clear weather, no flak, no fighters. Experienced bombardiers achieve excellent accuracy. But in combat over Germany, different story. Weather obscures targets. Clouds force missions to abort or bomb by radar. When visibility allows, flak bursts throw off the bombardiers. Fighters attack, forcing the formation to take evasive action. The bombardier cannot maintain the steady, level flight the Norden requires. And even when conditions allow proper Norden operation, the results show wide dispersion. LeMay develops a solution. Lead bombardier technique. Each bomb group has several highly experienced bombardiers, the best ones. Most missions, completed, steadiest nerves, proven accuracy. These men fly in the lead aircraft. They use the Norden, make the calculations, engage the autopilot, drop their bombs. The other bombardiers in the formation watch. The instant they see the lead's bombs released, they drop theirs. Togliers, they're called. Just watching and flipping the release switch. Not using the Norden at all. Pattern bombing by another name. The technique works. Not precision, but concentration. Instead of scattered bombs across a wide area, the formation's entire load falls in a relatively compact pattern. If the lead bombardier aims well, the target gets saturated. If he misses, the entire formation misses. But the concentration of explosives increases the probability of significant damage. The Norden Bombsight becomes, essentially, a tool for one man in each formation. The other 30, 40, 50 bombardiers are just releasing on command. Their Norden bombsights sit unused, 1,000 pounds of precision, equipment riding along as ballast. Someone calculates the economics. Each Norden costs approximately $8,000. Complex to manufacture. Requires precision machining. Skilled assembly. Each B-17 carries one. If formation bombing means only the lead aircraft's bombardier actually uses the Norden, the other bombsights represent wasted resources. 7 B-17 seconds in a squadron. 6 Norden bombsights not being used. $48,000 of equipment achieving nothing. Multiply across the entire 8th Air Force. Hundreds of bombsights riding to targets, returning to base, never actually employed in their designed function. But America keeps building them, because industrial capacity allows it. The Norden factory in New York, Victor adding machine. Remington Rand. They're producing more bombsights than needed. The Navy orders fewer than expected. Dive bombing proves more effective for anti-ship operations. The Army Air Forces take the surplus. Every bomber gets a Norden, even if operational doctrine means most go unused. Why not? The production capacity exists. The factories are built. The workers are trained. The supply chain functions. Might as well keep manufacturing. Weber, reading intelligence reports, finds this almost incomprehensible. Germany carefully allocates every resource. Precision instruments go where they're needed most. Gun sights for tanks, rangefinders for artillery, periscopes for U-boats, bomb sights for bombers, but only as many as required. Building excess would waste materials, labor, factory capacity. The Americans build excess because they can. No resource constraints, no strategic material shortages, no competition for factory space, just unlimited production of everything. September 1943. Weber receives orders to visit a Luftwaffe bomber base. Kampfgeschwader 3, still operating. He 111 medium bombers on the Eastern Front. The squadron commander wants technical support. The Lotfes 7C bombsights are performing. Well, mechanically. But the crews report accuracy problems. Weber arrives, expecting equipment issues. Instead, he finds operational realities. The squadron conducts mostly tactical missions, supporting ground forces, attacking Soviet supply depots, bombing railroad yards. They fly at medium altitude, 3,000 to 4,000 meters. The Lotfes 7C is designed for high-altitude operation, 6,000 to 8,000 meters. At lower altitudes, the ballistic calculations become less precise. Bombs spend less time in the air. Small errors in release timing create larger errors in impact point. More critically, the missions don't allow time for proper bombsight setup. A typical mission: take off before dawn, fly to the front, receive radio instructions on target location, approach, bomb, return. From target identification to bomb release, maybe 10 minutes. The Lotfes 7 needs 3 minutes minimum for proper setup. In practice, the bombardiers get 90 seconds. They enter approximate altitude and airspeed. They sight the target. They release. It's barely more sophisticated than eyeball bombing. Weber explains this to the squadron commander. The equipment is not the problem. The mission profile doesn't allow proper bombsight employment. You're asking the crews to achieve high-altitude precision bombing accuracy in medium-altitude tactical operations. Can you modify the bomb sight for our operational needs? Not without complete redesign. The Lotfes 7 calculates ballistics for specific altitude ranges. Different altitude requires different cam profiles in the mechanical computer. We would need to manufacture a tactical variant. How long? 2 years. Maybe 3. We'd need to complete the engineering, set up production, test the units. The squadron commander laughs bitterly. In 2 years, the war will be over. One way or another, we'll make do with what we have. Weber returns to Zeiss troubled. The Luftwaffe's bomber force is improvising, using sophisticated equipment in ways it was never designed for, achieving mediocre results. While the Americans, he knows from intelligence reports, fly their bombers exactly as designed. High altitude, massed formations, steady bombing runs. The Norden gets used in its optimal environment. Doesn't matter that the accuracy falls short of propaganda claims. It's being employed correctly. December 1943. A Luftwaffe intelligence summary crosses Weber's desk. Analysis of American bombing effectiveness. January through November 1943. The data comes from damage assessment, German factory reports, photographic reconnaissance. Total bombs dropped on Germany, approximately 180,000 tons. Approximate number hitting within 300 meters of aim point, 32,000 tons. Hit rate, 18%. The numbers shock Weber at first. Only 18% of bombs landing anywhere near where they're aimed. That's terrible accuracy. But then he considers the implications. 18% of 180,000 tons is still 32,000 tons of explosives hitting targets with some precision. And the Americans are just getting started. The report includes projections. If current trends continue, the 8th Air Force will drop 300,000 tons on Germany in 1944. At 18% accuracy, 54,000 tons on or near targets, plus another 250,000 tons in the general vicinity. Even terrible accuracy multiplied by massive tonnage equals devastating effect. The report's conclusion is carefully worded. American bombing accuracy does not meet the precision levels claimed by their propaganda. However, their industrial capacity allows them to compensate for lower accuracy through higher volume. The cumulative effect of sustained, high-volume bombing operations poses a strategic threat regardless of precision. Weber thinks about the Norden Bombsight. Americans spent over $1 billion developing, securing, and producing it. They treated it as the most important secret weapon of the war. They built elaborate security measures. Bombardiers swore oaths. Armed guards escorted the devices, all to protect a bomb sight that achieved similar accuracy to German equipment under similar conditions. But here's the irony. The security was meaningless. Germany obtained complete plans in 1938, built their own equivalent, and discovered the same truth the Americans would eventually learn. Bomb sights don't win wars. Industrial capacity wins wars. The ability to build hundreds of bombers per month, train hundreds of crews, send them into combat day after day, absorb losses and replace them. That's what matters. May 1944. Weber receives notice. He's being reassigned. Carl Zeiss is moving critical operations underground. Allied bombing of German cities is intensifying. Jena could be targeted. The company is establishing facilities in tunnels near Nordhausen. Safer from aerial attack. Production of optical instruments, gun sights, bomb sights will continue in the underground factories. Weber visits the new facility in June. Tunnels carved into rock, electric lighting, ventilation systems, assembly stations set up on concrete floors, forced laborers from concentration camps doing the heavy work. skilled German technicians supervising. It's a vision of industrial desperation. Germany's precision instrument production reduced to underground workshops, trying to maintain quality while the surface world burns. Above ground, he learns the Americans are preparing for D-Day, the invasion of France. Thousands of bombers supporting the landings, bombing coastal defenses, attacking transportation networks, isolating the battlefield, each bomber carrying a Norden bombsight, most of those bombsights not actually being used for precision aiming, just riding along while the bombardiers release on the lead aircraft's signal. It doesn't matter. America has the industrial capacity to build bombsights that sit unused. Germany barely has capacity to build bombsights for actual employment. The invasion succeeds. Allied forces establish themselves in France, begin pushing inland. The strategic bombing campaign intensifies. American bombers range across Germany. Railroad yards, oil refineries, aircraft factories, cities. The 8th Air Force grows larger, more bomb groups, more aircraft, more missions. August 1944. Exactly 1 year after Weber examined the captured Norden. Luftwaffe bomber operations have nearly ceased. Fuel shortages, pilot losses, aircraft attrition. The remaining bombers conduct desperate missions, attacking Soviet forces in the east, trying to slow the Russian advance. The Lotfes 7 bomb sites sit unused. The crews bomb visually. Low altitude, drop and run. No time for sophisticated calculations. No conditions allowing proper bomb site employment. Weber continues working on optical instruments. Not bomb sights anymore. Those aren't needed. Gun sights for the few remaining tanks. Periscopes for U-boats. Rangefinders for anti-aircraft batteries. The underground factory produces what's needed for defense. For survival. Not for offensive operations. He receives intelligence reports occasionally, less frequently as German intelligence networks collapse, but enough to track American operations. The 8th Air Force is conducting 1,000 bomber raids, 1,000 bombers in a single mission, each carrying a Norden bombsight, each bombsight representing $8,000, 1,200 precision parts, months of manufacturing effort. Most going unused as bombardiers simply toggle on the lead signal. The waste would be shocking if it wasn't so revealing. This is what unlimited industrial capacity looks like. You can afford waste. You can build redundancy. You can equip every bomber with every possible device, whether it's used or not, because the alternative, running short of equipment, is unacceptable. Better to have too much than too little. January 1945. Soviet forces are pushing into Germany from the east, American and British forces advancing from the west. The strategic bombing campaign reaches its peak. Daylight raids by the Americans. Night raids by the British RAF. German cities are being systematically destroyed. Not precision bombing anymore. Area bombing. Incendiaries. High explosives. The distinction between military and civilian targets has collapsed. Dresden, Hamburg, Berlin, cities turned into ruins. The Norden bombsight's original purpose, precision attacks on specific industrial targets, has given way to area saturation, but the bombsights still fly on every mission, still get maintained between missions, still represent billions of dollars of investment in a capability that combat operations have rendered largely obsolete. Weber is ordered to Berlin in March. Luftwaffe Technical Command wants his assessment of captured equipment. American fighters have been shot down. P-51 Mustangs, P-47 Thunderbolts. The gun sights, the radios, the oxygen systems. Everything showing the same pattern. High-quality manufacturing, mass production, no shortcuts despite huge production volumes. He examines a gun sight from a P-51. It's a gyroscopic computing sight, similar in principle to German designs, not better, Not more advanced, just well-made, consistent quality. The pilot reported before being captured that it was his third aircraft. The first two had been shot down. He'd bailed out, returned to England, and been assigned new fighters. Each time, the equipment was identical. Same quality, same reliability. That's the difference, Weber realizes. Germany builds excellent equipment, but can't replace it fast enough. A pilot loses his aircraft. He might wait weeks for a replacement, or he gets assigned an older model, or equipment that's been rebuilt from salvage. The Americans lose an aircraft. They have another, one ready the next day. Same model, same equipment, identical to what was lost, infinite supply. He writes a final report, not official, just his personal assessment for the officers who trust him. The captured American equipment shows no technical superiority. What it shows is industrial superiority. They can manufacture complex equipment at a rate that allows immediate replacement of losses. A pilot in combat knows if he's shot down, he'll have a new aircraft within days. A bombardier knows if his bomb sight is damaged, there's a replacement available immediately. This certainty affects morale, affects operations, affects everything. Our pilots know lost equipment may never be replaced. They fly careful, conserve resources, avoid unnecessary risks. American pilots know equipment is expendable. They take risks, press attacks, lose aircraft, and get new ones. Over time, this difference accumulates into overwhelming advantage. April 1945. The war is ending. Soviet forces are in Berlin. American forces are across the Rhine. German resistance is collapsing. Weber is in Bavaria when he receives word. Zeiss facilities in Jena have been captured by American forces. The underground factory near Nordhausen discovered. Thousands of Lotfes 7 bomb sights, never installed in aircraft, sitting in storage. The Americans will take them, study them, compare them to their Norden. They'll learn what Germany knew from the beginning. The two bomb sights are comparable. Different design philosophies, similar capabilities. Neither revolutionary, both adequate. The difference was never the technology. The difference was the industrial system behind the technology. May 8, 1945. Germany surrenders. The war in Europe is over. Weber is processed as a prisoner. American technical intelligence teams interview him. They want to know about German optical technology, Zeiss instruments, bomb sights, gun sights, rangefinders. He answers honestly, describes the Lotfe 7 development, explains the design philosophy, details the manufacturing processes. The American officers are surprised when he tells them about the 1938 acquisition of Norden plans. You had our bomb sight plans before the war started. Yes, complete plans. We built a mock-up, evaluated it thoroughly. And you didn't copy it? We didn't need to. We were already developing equivalent technology. Your bomb sight is excellent. Ours is equally good. Different approach, same results. So the security was pointless? The officer asking is from Army Air Force's intelligence. Weber considers carefully. The security was pointless in terms of keeping the design secret. We had that information since 1938, but perhaps the security had other purposes. Morale, making your bombardiers feel they had a special weapon, making your public believe you had technological advantage, propaganda value. The officer nods slowly. That's an insightful way to put it. The Norden was sold to the American public as a miracle weapon, could drop bombs into pickle barrels, win the war through precision. Reality never matched the claims, but belief in the weapon mattered. That belief justified the strategic bombing campaign, convinced Americans that bombing could win without invasion, supported funding for bomber production. So even if the technical advantages were exaggerated, The propaganda advantages were real. Weber is released in July 1945, returns to Jena. The city is now in Soviet occupation zone. Zeiss will be split. The Soviets take control of the Jena facilities. Zeiss will re-establish in West Germany. Many of the engineers and technicians move west. Weber goes with them. He helps establish new Zeiss facilities in Oberkochen. Back to work on optical instruments. Civilian applications now. Cameras, binoculars, microscopes. The skills developed for military equipment translate to peacetime products. The precision, the quality control, the careful, manufacturing. He never works on bomb sites again. The technology that consumed 5 years of his life. Development, testing, production, combat evaluation. All obsolete now. Strategic bombing ended with the war. Future wars, if they come, will be different. Jet aircraft. Guided missiles. Eventually, nuclear weapons. The kind of high-altitude precision bombing that required sophisticated bomb sights becomes irrelevant when one weapon can destroy an entire city. Weber thinks sometimes about the captured Norden he examined in August 1943. The device that revealed nothing Germany didn't already know. He wonders what happened to it, probably in storage somewhere, or destroyed, or sitting in a museum, a relic of a specific moment in military technology, when bombing accuracy mattered, when precision instruments could give tactical advantage, before overwhelming firepower made precision irrelevant. The real revelation from examining Norden wasn't about the technology. It was about what the technology represented. An industrial system that could afford to produce complex precision instruments in quantities that exceeded operational needs. A nation with resources so abundant that waste was acceptable. Strategic material so plentiful that building redundant equipment was standard practice. Germany never had that luxury. Every gram of strategic material was allocated. Every hour of skilled labor is carefully managed. Every piece of equipment built because it was needed, used until it broke, rebuilt if possible, replaced only when absolutely necessary. Scarcity thinking versus abundance thinking. And abundance won. Not because American engineers were smarter, not because American technology was better, because American industry was bigger factories, more machine tools, more skilled workers, more raw materials, more of everything. The Norden Bombsight was just one example, one device among thousands, each showing the same pattern. Adequate technology, massive production, overwhelming volume. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe. 1952, Oberkochen, West Germany. Carl Zeiss, West German headquarters. Weber sits in a modern office, very different from the underground tunnels of 1945. The company has rebuilt. New facilities, new markets. The Korean War has created demand for optical equipment. Military contracts returning, though nothing like the war years. Weber now leads the Precision Instruments division. His expertise from Lotfes development translates to civilian applications, surveying equipment, astronomical telescopes, industrial measurement systems. A visitor arrives from the United States. Dr. Robert Williams, optical engineer from Bausch & Lomb, American company, exploring European partnerships. Williams wants to discuss technical collaboration, license agreements, shared manufacturing. Over. Lunch. The conversation turns to the war. Williams mentions he worked on Norden Bombsight production during the war years. Quality control engineer at the Victor Adding Machine Factory in Chicago. Small world, Weber says. I worked on the Lotfernrohr 7, Germany's equivalent. Williams is curious. I've seen the Lotte 7. We captured hundreds after the war. Studied them. Very elegant design, simpler than the Norden. How did it perform? Weber considers his answer. Similar to yours. Under ideal conditions, excellent accuracy. Under combat conditions, adequate accuracy. Both systems limited by the same factors: environment, crew training, mission parameters. Williams nods. That matches what we learned. The Norden never achieved the accuracy we claimed in testing. Too many variables in combat. But the brass didn't want to hear that. They'd invested too much. Political capital, financial resources, public promises. Admitting the bombsight didn't work as advertised would have undermined the entire strategic bombing doctrine. Did you know Germany had the Norden plans before the war? Weber asks. Williams looks surprised. I'd heard rumours. Never confirmed. Weber explains about Hermann Lang, the stolen plans in 1938, the Zeiss evaluation. Williams listens, shaking his head. So all that security. The armed guards, the bombardier's oath, the storage vaults, all meaningless. You already knew everything. We knew the design, Weber corrects. But that wasn't enough to matter. You had the industrial capacity to produce thousands. We could barely produce hundreds. That was the real difference, not the technology. The scale. Williams leans back. You're right. I saw it in the factory. We were manufacturing Norden bombsights on assembly lines. Progressive assembly. Each station added specific components. Workers specialized in single operations. Repetitive. Efficient. We built quality through process control, not individual craftsmanship. That's American manufacturing. Philosophy. Break complex tasks into simple steps. Train workers to execute those steps perfectly. Achieve consistency through system, not skill. It works for simple products. Rifles. Uniforms. Trucks. But precision instruments? That's supposed to require skilled craftsmen, individual attention, hand-fitting. Yet you made it work, Weber observes. How? Williams explains. We developed custom fixtures, jigs and gauges that guaranteed alignment, pre-calibrated components that required no adjustment during assembly, standardized testing procedures that identified defects before final assembly. Instead of relying on a master craftsman to build each bombsight correctly, we designed the manufacturing process so that average workers couldn't build it incorrectly. The system enforced quality. Weber recognizes the philosophy. We tried similar approaches. Limited success. Our machine tool accuracy wasn't sufficient for the fixtures we needed. Our material consistency wasn't reliable enough for interchangeable components. We'd designed for standardization, but reality forced customization. Williams nods. American industry invested decades in machine tool development, precision grinding machines, optical comparators, coordinate measuring systems. By the 1930s, our machine tools could hold tolerances that required hand-fitting in Europe. So our mass production was actually precision mass production. We could manufacture complex parts to tighter tolerances than craftsmen could achieve manually. That capability made everything else possible. The bomber production, the tank production, the Norden Bombsight production, all based on machine tool superiority that nobody talked about because it wasn't glamorous. The conversation continues through the afternoon. Two engineers from opposite sides of the war comparing notes. Weber learns that American bombsight production peaked at 700 units per month in mid-1944. Far more than needed. The surplus went to storage. Some were modified for Navy use. Others sat in warehouses until they became obsolete. When production ended in 1945, thousands of completed bombsights existed with no aircraft to install them in. They were eventually scrapped. melted down for the strategic metals, $7,000 of precision equipment per unit, multiplied by thousands of units, all waste. But acceptable waste, because America could afford it. Williams learns that Lotte 7 production never exceeded 250 units per month. Peak production, summer 1943. After that, it declined. Material shortages, skilled labor shortages, bombing of supplier factories. By late 1944, production was under 100 units monthly, not enough to equip new aircraft, barely enough to replace combat losses. And many of those late-war units showed quality degradation, forced laborers replacing skilled technicians, lower-grade materials substituting for specified alloys, shortcuts in manufacturing because meeting production quotas mattered more than meeting specifications. Weber admits something he's never told anyone outside Germany. By early 1945, we were installing Lotte 7 bombsights in aircraft with the knowledge that perhaps 30% wouldn't function properly, gyroscopes that wouldn't stabilize correctly, computers with gear trains that are bound under load, optics with distortion from improperly ground lenses. But we installed them anyway because having a defective bombsight was better than having no bombsight. The crews would test them during pre-flight. If the sight worked, they'd use it. If not, they'd bomb visually. The entire quality control system had collapsed. We were just trying to maintain appearances. Williams reveals similar information from the American side. Norden had its own problems. The gyroscopes were sensitive to temperature. At altitude, in -40-degree cold, some units wouldn't maintain stabilization. The autopilot connection was vulnerable to electrical interference. In aircraft with damaged wiring, the bombsight might command random flight inputs, the optical system fogged in humid conditions. Combat damage would throw off calibration in ways that weren't immediately visible. The bombardiers would think their sight was working correctly, but the calculations would be wrong. We estimated that 20 to 30% of bombsights on any given mission had some malfunction. Not always catastrophic, sometimes subtle, but enough to degrade accuracy. So, both sides were using equipment that didn't work as designed, Weber says. Flying missions with defective instruments, achieving results that fell short of expectations. Yes, Williams agrees. But here's the crucial point. America could afford the failure rate. Germany couldn't. If 30% of our bombsights malfunctioned, we had enough bombers that the other 70% still delivered, devastating tonnage. If 30% of your bombsights malfunctioned, you didn't have enough aircraft to compensate. Same failure rate, different strategic impact. Because of industrial scale, Weber understands this is the fundamental lesson. Technology matters less than capacity. Quality matters less than quantity. A perfect weapon you can only build in small numbers loses to an adequate weapon you can build endlessly. The Lotte 7 might have been slightly simpler, slightly more reliable, slightly better suited to combat conditions than the Norden. Doesn't matter. Germany built 2,000 total. America built over 50,000 Nordens. 50,000 versus 2,000. That ratio decided more than all the engineering excellence Germany could muster. The two men part as colleagues, professional respect between former enemies. Weber returns to his work with renewed perspective. The precision instruments Zeiss builds now for civilian markets incorporate lessons from the war. But, more importantly, they incorporate the understanding that engineering excellence must be matched by manufacturing excellence. Design sophistication means nothing if you cannot build the design reliably, repeatedly, at scale. This becomes Weber's guiding principle for the next 2 decades. Quality through the system, precision through process, excellence through consistency. The very principles he saw in the captured Norden The Principles That Won the War, 1973. Weber retired from Carl Zeiss after 33 years with the company. His legacy includes dozens of precision instruments, surveying equipment used worldwide, microscopes advancing medical research, optical systems enabling scientific discovery. None of it military, all of it applying expertise gained from designing bomb sights that helped lose a war. The irony is not lost on him. Skills developed for destruction, repurposed for knowledge. Technology meant to help bombers find targets, refined to help scientists find truth. He writes a memoir in retirement. Never published, just personal reflections. One chapter discusses the captured Norden bombsight, that August day in 1943 when he stood in a Rechlin hangar, examining American engineering, understanding German defeat. Not from the technology in front of him, from what that technology represented. Industrial capacity was so vast that precision instruments became disposable. Manufacturing sophistication was so deep that complexity became routine. Resources so abundant that waste was policy. Germany never had a chance against such power. Not with better tactics, not with better technology, not with better soldiers. The mathematics were inexorable. More factories, more materials, more production, more everything. Quantity has a quality all its own, he writes, quoting Stalin. A brutal truth, but truth nonetheless. The memoir ends with a question. If Germany had obtained not just the Norden plans, but complete access to American manufacturing processes, would it have mattered? His answer: no, because the manufacturing processes depended on infrastructure Germany didn't possess. Machine tool industries are decades advanced, steel production measured in millions of tons, electrical generation capacity beyond imagination, transportation networks moving materials efficiently, most critically, an economy that could sustain military production while simultaneously raising civilian living standards. Germany's war economy required sacrifice. America's war economy created prosperity. That difference, more than any weapon system, determined the outcome. Weber died in 1989, age 80. His obituary mentions his work at Carl Zeiss, his contributions to optical science. Nothing about bomb sights, nothing about the war. That chapter, closed. But the lessons persist. In manufacturing, in engineering, in understanding that wars are won not by miracle weapons, but by industrial systems. The Norden bombsight wasn't America's secret weapon. American industry was. And that secret was never secret at all, just ignored by those who preferred to believe in technological magic rather than mathematical reality.